So let's review the types of chemical bonds. First of all, what is a chemical bond? Why does it happen? Chemical bonds form because they lower the potential energy between the charged particles that compose atoms. Atoms are composed of positive protons and negative electrons. And when two or more atoms join together in a molecule by a chemical bond, they do so because it lowers the potential energy. We have a complex set of interactions. The electrons between the two atoms are going to repel each other. The nuclei are going to repel each other because like charges repel. But the electrons of one atom will be attracted to the nucleus of the other atom, and so we have that attraction. A bond will form if the net result of these interactions is a reduction in energy. So ionic bonds involve transfer of electrons. We just looked at periodic trends. That's not what I meant to do. We just looked at periodic trends, and we know that metals tend to have low ionization energies. They will relatively easily lose electrons to become cations. Nonmetals have negative electron affinities, meaning they're very likely to accept an electron and become an anion. Anions are negatively charged. Cations are positively charged. There's a force of attraction between them. In these ionic compounds, the metal transfers electrons to the nonmetal. It just gives them to the nonmetal. You can take them somewhere else if you want, but they're yours. But then because of the charge that results, there's an attraction, and that attraction is the ionic bond, the attraction between the charged ions. So here we have a little summary of the three types of bonds. We just talked about ionic bonds. Electrons are transferred. This happens between metals and nonmetals. We can have bonds between nonmetals, carbon and oxygen, hydrogen and oxygen, etc. Those are going to be covalent. Co is a prefix meaning to share, and valent refers to the valence electrons. So this is sharing valence electrons. And then we have also bonds between metal atoms. And this is called a metallic bond, and here the electrons are pooled. And we'll talk about that one later. In a covalent bond, we have electrons being shared because neither nonmetal atom wants to be a cation. They both want to be anions, and so by forming ions, they're not going to attract each other. So what they'll do is they'll share electrons, and those shared electrons interact with both of the nuclei. So here we have two nuclei, and here's an electron that's being shared. But if it's up here, the amount of attraction it has to each of these is not at a maximum. We'll get maximum attraction in this lowest potential energy if that electron is between the two nuclei. If we pull it off over here, that's less attraction and a higher potential energy. And so we find that the minimum potential energy is when those shared electrons are between the two atoms. And those electrons being shared between the atoms hold the two atoms together, and that is the covalent bond. It's the sharing of the electrons. In metallic bonding, this occurs between metal atoms. Metals lose electrons easily. They'll form cations. But if you don't have any anions to form negative ions, there's not going to be anyone to take those electrons. And so the electrons are just kind of running loose within the metal. We call this the electron C model, and we'll have an illustration of this later. But all the atoms in this solid are basically going to pool their valence electrons. I think of it a little bit like houses in a neighborhood and families. And so each family, each household is an atom. And the electrons are the children. And those valence electrons are the older kids, and the moms send them outside to play. This is what happened when I grew up. Mom would say, go outside and play. Come back when the streetlights come on. And you'd play outside all day, and you'd find lunch at somebody's house. They went out and played. But then there's this attraction between the nuclei, and these pooled electrons that are kind of free to roam about, but there's this general attraction between the nuclei. Everybody kind of feels responsible for the kids running around in the neighborhood. And so those electrons, unlike the covalent bond, where the shared electrons need to be between the two atoms to minimize the energy, here the electrons are, we say they're delocalized. They don't have to stay in their own yard. They're free to move around.